For our next section, we're going to get into section 2.6, multiplication and division properties. Our objective is to apply the multiplication and division properties of segments and angles. For homework, I want us to practice number 2 through 16, the evens, on page 92 through 94. Alright, let's start talking about the multiplication property theorem. And here's what it says. A segment or angles are congruent, and their like multiples are congruent as well. So let's draw a picture for that. So let's say that we have two segments. Technically here, I guess we actually have a total of 6 segments. 2 little ones, 2 more little ones, and then the big long ones. Now, let's say, here's what I know about them. Let's say I know that the big long segments are congruent. AB is congruent to DE. Let's say I also know that B is going to be the midpoint of AC. And I also know that E is going to end up being the midpoint of DF. So let's put those tick marks in here. Here we go. So here's what I know. AB and DE are congruent. We also know that we have midpoints. And we know by definition of a midpoint, midpoints create 2 sets of equal pieces. Now, if I already know one, I know the other. So what I'm actually doing here is I'm creating doubles. I start off with a small segment. I have a key word such as midpoint. Therefore, what I'm going to be able to conclude using the multiplication property is that the doubles, AC and DF, are going to be congruent, and that's going to be by the multiplication property. For our next property, we have the division property, and here's what it says. If segments or angles are congruent, then their like divisors are congruent as well. And let's draw a picture for this one. Now let's say for my pictures that I have 2 sets of angles, and again, each big angle has 2 little angles in it as well. Now, let's say here's what I'm going to know about it. Let's say I know that those big angles, angle AFD is congruent to angle ZXC. And let's say that I also know that FS bisects angle AFD, and also that XB is going to bisect angle ZXC. Now, we know the big angles are congruent, and we know key words about those big angles. So let's think about what that actually means to us. We know the word bisect means to create 2 equal. If they start off equal, and we chop them in half, we know that their halves, or their divisors, are also going to be congruent. So here's what we can conclude. We can conclude that angle AFS, one of the smaller ones, is going to be congruent to ZXV, the other smaller one. And you can actually mix and match this. We can say that AFS is congruent to VXC, SFD is congruent to VXC, or SFD is congruent to ZXV. So we can mix and match those little divisors. So here's some helpful hints for multiplication and division. Here we go. Multiplication and division uses key words such as midpoint, trisect, or bisect. You're never going to use multiplication or division when you don't have those key words. The multiplication property is used when the angles or segments in the given statements are smaller than in the conclusion. So what that means is you know one of the little segments or angles are congruent. You have key words about those big segments. Therefore, the big ones are going to be congruent by multiplication. And for division, the division property is used when the angles or segments in the given are bigger than in the conclusion. So again, how this one works is you know that the big segments or angles are congruent to start. You know key words about those big angles or segments. Therefore, the little pieces are going to be congruent by division. Alright, so let's do some examples next. Alright, so here's what we have. We have our very first proof here. We are given that JK is congruent to KM. Let's put our tick marks there. JK, the big segment, is congruent MK, the other big segment. We also know that OP bisects JK and MK. We're trying to prove that those little pieces, JO, is congruent to PK. Now, let's start off with our statement and reason columns. Alright, so now when I start my proof, what I see here, with those big segments congruent and keywords about both big segments, I have these little pieces. Bisecting means cut to two equal pieces. So we have two equal pieces here, and since we have congruency on the other, as long as they start off big and congruent, their divisors are also going to be big and congruent. So this is a case where we can mix and match based on what we're trying to prove. After our givens, we can go straight into our conclusion. What we're trying to prove is that JO, one of the divisor pieces, is going to be congruent to PK. We started with the big pieces, keywords. We can conclude the small pieces by division. Alright, for our next one, we're given that SZ is congruent to ST. We're given that XY is congruent to VW. Y is the midpoint of XZ, and V is the midpoint of TW. We're trying to prove that SX is congruent to SW. Well, let's start marking some stuff up. So first and foremost, let's mark up. SZ is congruent to ST. Then we have XY is congruent to VW. Now, we have some keywords here. Those keywords deal with ZX, and it also deals with TW. So let's make our statement and reason columns. Plug in those givens, and let's get rolling on this. Alright, here we go. Now, since we know keywords about those big pieces, that we had a midpoint, and we know that we have congruent little pieces, by multiplication, we know that their doubles are going to be congruent. So for my next step here, I can end up saying that ZX is going to be congruent to TW, and for my reason, I can say multiplication. Oops, hold on a second. There we go. Abbreviation for multiplication is MULT with a period behind it. Now, what we're trying to prove here is that SX is going to end up being congruent to SW. Well, SX is this longest segment that we have here. SW is the longest segment we have on the other side. What essentially are we doing? Well, what we're doing is we're going to combine a congruent piece with a big congruent piece. A congruent piece with a big congruent piece. And by combining them, we're going to be adding them. So we can say that SX is going to be congruent to SW by addition. That one wasn't easy, but wasn't horrible. Hopefully we got that one. Alright, this is going to be our last example here. So let's go ahead and start off with our statement and reason column. Let's read and mark up our picture. Angle NOP, this angle from right in here, is congruent to angle RPO, this angle right in here. We have that TP bisects angle ROP, so a key word about that big one. OS bisects angle NOP, a key word about our other big one. And then we have some complementaries. Angle 1 is going to be complementary to angle NSO. And we also are given that angle 3 is going to be complementary to angle RTP. Now, we're trying to prove NSO, one of the repeats, is going to be congruent to angle RTP, one of the other repeats. That's where we want to end. Let's take a second, let's write down our givens. Alright, so here we go. Now, we're going to start talking about just using these first 3 givens. Again, we knew the big angles, we knew keywords about those big angles, so we're going to try and carefully select, using the division property, angles that are going to help us move forward. Now, we have an angle 1 and an angle 3. Let's say they're congruent. Now, I carefully selected those. Why do you think I chose those angles instead of the other ones? I could have selected SOP and TPO, but I didn't select those. Why not? Well, if you said that it wouldn't help me cancel out, you were absolutely right. Now, we're going to look for those repeats. Here's my repeats. Within the complementary, I have angle 1 showed up in a congruency. They cancel each other out. Angle 3 shows up in a complementary and a congruency. They cancel each other out. What I'm left with is what I'm trying to prove. Angle NSO is going to be congruent to angle RTP. Hopefully you remember this reason. We have complements of congruent angles. So here we go. If two angles are complementary to congruent angles, they are congruent. Now, this one was definitely very tricky. I'll give it to us. Anytime that we see that we have a lot of givens, it's either going to be one of two things. Extremely easy, or going to require some thought. Hopefully we got it. Now, just like yesterday's, I'm going to put the answers in the back here. Now, we had 2 through 16 the evens for our homework. Pause it and copy it down if you want, or else it'll be up again tomorrow. But here's the answers that I kind of want to make sure that we're going to get. Look through these answers in the book and make sure we're all okay with them.